Okay, so now time for our second speaker. We have Michelle Gygax. She is a PhD candidate from the University of Bern, but she's also doing a year of study here in Guelph with Dr. Georgia Mason. And in a galaxy not so far away, the muscle mice are using the force to show us what they really want to do. So over to you, Michelle.
Thanks, Rosie, for the introduction. I'm glad they couldn't use the force because that would have been a mess in the lab. So in my project, I am interested in looking at animal behavior and finding ways how we can use it to assess resource preferences in mice. And understanding an animal's resource preference is key to improving their housing conditions because animals usually prefer resources that are good for them. And if we know what they prefer the most, we have the best chance to improve their housing conditions the most. However, that also poses a challenge because animals cannot speak. So how do we ask them what they want? Lucky for me, there are a lot of researchers out there that have worked on this before, and they have come up with a lot of good ways to do that. One way is to look at how much an animal is willing to pay for access to a given resource, and then we can compare this across resources and figure out what they like the most. What we know is that animals work very hard and can be very persistent if they want something. As you can see here in this video, the pug is trying really hard to get inside. So if we now want to know how much, so we could assess how much she is willing to pay to get inside the door. And this is what we call maximum price paid. And this concept has been borrowed from human consumer demand theory, where it is called reservation price. And this is basically the highest price that the buyer is willing to pay for a given good. And it indicates the perceived value of that good for the buyer. In animal studies, this is called breakpoint, which is the highest level of effort an animal is willing to exert before they stop working for a reward. And it is a valid measure because it correlates with the animal's motivation as well as with factors such as resource quality and hunger or deprivation state. So since animals cannot pay with money like we could, we have to find out other ways how we can assess the maximum price paid. And this is usually done in training animals to do some kind of task, for instance, pushing through a weighted door. And then we can increase the mass on this door and see at which point the animal stops pushing through. And this would then be the maximum price the animal is willing to pay for access to the resource. And if we do that across multiple resources, we can rank them according to preference. And this has been done before across various species. And researchers have found, for instance, that mink like to swim, cows like to graze or lay down on softer floors, that hens like to access nesting boxes when they want to lay their eggs, and that mice like complex cages. So I piloted this method and I found a few limitations with my mice. First of all, this method is incredibly time consuming because we are increasing the load over consecutive days. And depending on the resource, this can take longer or less long, and we never know when the animal is going to stop. So planning an experiment like that is really difficult. Also, the measure is discontinuous because the load is increased in steps, which was a bit of a problem to see smaller variations between resources. And when I was using these doors, I found that there was a risk of the animal being hurt because we put actual mass on the door. So the heavier the mass got, the higher the risk for the mouse to be stuck because mice have really thin and long tails. And when the door gets heavy, they would have issues getting out. So we tried to avoid that altogether. And therefore, I developed a door mechanism that worked electronically and would assess the force the mice exerted via load cell directly on a continuous scale. And the benefit here was that we could basically block the door for 48 hours and then assess the force the mice exerted in 48 hours directly via this load cell. So we didn't have to add any force on the doors, and the mice were not at risk. Also, this made the whole experiment less time consuming. What these doors could also do was recording the number of attempts animals had at each door. And we were interested in looking at whether this would be a suitable alternative to look at resource preference in animals. because the thought behind that is if you have to go to the bathroom really badly, you would not only rattle the door more hard, but also go back more often if it gets very urgent. And there is some indication that this could work, because in calves, they have found that the numbers of attempts to drink from a drinker actually increase depending on the hunger state of the animals. So we wanted to look at that. So to figure out which resources the mice prefer the most, we measured willingness of the animals to pay via maximum force exerted on our load cells, and looked also at number of attempts. And we assumed that mice would try harder and more often to access resources they really liked. And to do that, we had these 6-chambered cages, where we had 5 chambers with resources, and 1 chamber was an empty control. And the resources under test were a gnawing stick, a shelf, a climbing frame, a running wheel, and a burrow. And we had a total of 20 such cages with 40 mice that were housed in pairs. And we used both sexes and 2 very common laboratory mouse strains to improve generalizability of the study. And the data was collected via our load cell 24/7 automatically during 48 hours of block, and recorded on an Arduino chip. And the Arduino chip was also attached to a RFID antenna system, so that we would always know which mouse would go in the door, how much force they would exert, and when they would leave the door again. We analyzed the data running linear mixed effect models with resource, sex, and strain as fixed effects, mouse ID cage system, and batch as random variables. The number of attempts data we had to log transform, so it met model assumptions of normalcy. And then to look at how much of the variance number of attempts would explain in our outcome variable maximum force exerted, we added it to a model and looked at the adjusted R-squared. So these are the results. On this bar plot, you can see maximum force exerted in grams on the y-axis and the resources on the x-axis. And these are the mean numbers across the animals. And you can see here that mice tried most often to reach the burrow, followed by the running wheel and the climbing frame and the other resources. And the results for burrow, running wheel, and climbing frame were significantly different from the empty control compartment. The maximum grams ever reached by a mouse were 349.6 grams, which is quite impressive considering mice are only 20 grams themselves. So in this graph here, you can see the same for number of attempts. And here as well, you can see that mice tried the most often to enter the compartment with the burrow, followed by the running wheel and the 3 other resources. The burrow, the running wheel, and the climbing frame were significantly different from the empty control compartment. And in both measures, we also found significant sex and strain interactions. However, I will have to do the analysis for that and look into that in the future. Then when we looked at the adjusted R-square, we saw that our model actually explained quite a lot of variation. About 76% was explained. And the variables also correlated quite nicely, except for the less preferred resources. And if we sum that up, we found a clear preference in mice for the burrowing cage, the running wheel, and the climbing frame. And also we argue that we refined the method a bit, because in our doors no mouse was ever hurt. There was no force on them directly. And also it assessed maximum force exerted quite successfully. Then also numbers of attempts predicted maximum force exerted quite well, indicating that it might be a suitable proxy to assess resource preference in mice. However, to really be sure that it measured the same underlying construct, I would like to conduct a future study where we, for instance, could manipulate the motivation in mice and then see whether this variable co-varies with the actual motivation in the animal. So with this, I would like to thank everyone who supported me, and also the funders, and of course also the mice, because without them it wouldn't have been possible. And I would like to take your questions.